In 1879, a zoologist in Melbourne examined two dead snakes shipped from the dry channel country of inland Australia. He named the species, described it, and filed it away. Then it vanished. For the next 90 years, not one living specimen was ever found. Some herpetologists suspected the description was simply a mistake, a species that never existed. Then, in 1972, researchers found it alive at last, coiled in the cracked black clay near the Queensland-South Australia border. When they milked its venom, they found something that still unsettles toxicologists today, drop for drop. It is the single most toxic venom of any snake on the planet, roughly 50 times more potent than a king cobra's, with enough poison in one bite to kill roughly 100 adults. This snake, the inland taipan, is only one of 12. Scattered across Australia is a hidden catalogue of ancient, overpowered predators science is still working to explain. If you're new here, welcome. This channel investigates the geography, deep history, and unexplained mysteries hidden inside our planet's most dangerous landscapes, the places and creatures that scientists are still working to understand. If that's the kind of journey you're after, subscribe now, because this particular mystery only gets stranger from here. To understand why, you first need to understand the ground itself. Australia is the flattest, driest inhabited continent on Earth, and one of the oldest. Roughly 35 million years ago, it tore free from Antarctica, the last fragment of the ancient supercontinent Gondwana, and began drifting north in near total isolation. In the continent's far west, exposed rock contains mineral grains dated at over 4 billion years old, among the oldest material ever found on the planet's surface. This is a land of red deserts the size of small nations, wind-worn mountain ranges reduced to stumps, tropical reefs, and rainforests older than flowering plants. That isolation produced two very different evolutionary stories, and together they account for all 12 of our species. The first is a story of deep time. The platypus carries at least one venom component that molecular science now traces back roughly 190 million years, quite possibly older than the first bird. The Sydney funnel web spider belongs to an order of spider so ancient its fossil record predates the dinosaurs, a lineage now extinct almost everywhere else on Earth and surviving mainly in these forests. The jackjumper, a type of Australian bull ant, belongs to the single oldest branch on the entire ant family tree, wiped out globally, except here. The second story is one of speed. Australia's front-fanged snakes are, on a geological clock, newcomers arriving from Asia across ancient land bridges a mere 12 to 25 million years ago into a continent with almost no other snakes to compete against. Finding the door wide open, they diversified explosively into every true sea snake alive today, and into land species including the coastal taipan, the inland taipan, the eastern brown snake, and the death adder. Layer onto that the box jellyfish and the nearly invisible Irukandji drifting through northern waters, the blue-ringed octopus tucked into tide pools, the redback spider hiding beneath outdoor furniture, and the stonefish lying motionless on reef sand. And you have a continent where 12 separate evolutionary experiments each arrived, independently, at the same extreme. Long before any of this was measured in a laboratory, the peoples who have lived on this continent for over 65,000 years already knew it. Aboriginal Australia is not one culture, but hundreds over 250 distinct language groups, each with its own law, its own country, its own stories. Yet across an extraordinary number of them, one figure recurs, an ancestral serpent, immense and powerful, who moved across the land in the dreaming and carved its rivers, gorges, and waterholes into being. In Western Arnhem Land, she is known as Ingalyod. Other language groups know her by different names, shaped by their own country and law, yet sharing a common thread, a creator being tied to water, capable of great generosity and great danger alike. This was never simple fear. In most traditions, the ancestral serpent is a giver of life she calls the monsoon, fills the waterholes, allows the land to bloom. But she also demands to be approached with correct protocol, because a being with that kind of power can just as easily withhold the rain, flood the country, or strike at those who show disrespect. This ecological knowledge was never limited to snakes. Coastal and desert communities alike held tested knowledge of which spiders, ants, and marine stingers demanded caution, and which plants could ease a bite or a sting practical bush medicine refined across thousands of years, long before any of it reached a Western textbook. Certain waterholes and sites were, and are, treated with particular care, their dangers encoded not in signage but in story, ceremony, and lore carried across generations. Some of the earliest known rock art, depicting an ancestral serpent in Arnhem Land, is thought to date back 6,000 to 8,000 years, roughly the period when rising seas, at the end of the last ice age, were redrawing this very coastline. The story and the geology, in this case, may be remembering the same event. The animals themselves were named and understood long before Western science arrived. The fierce snake of the interior, the one that vanished from the scientific record for 90 years, was never a mystery to the Aboriginal people of the Channel Country, who called it Dandarabilla and knew exactly which cracks in the black clay to avoid. Long before any laboratory confirmed its venom as the most toxic on Earth, the people who shared its country had already reached the only reasonable conclusion: leave it alone entirely. The historical record bears this out, case after case. On the 5th of February 1927, in the Sydney suburb of Thornley, a toddler sitting on the back laundry steps was bitten on the finger by a spider he'd tried to crush in his small hand. He died shortly after the first confirmed human death attributed to the Sydney funnel web spider, a species whose burrows sat, unnoticed, beneath the very foundations of a rapidly expanding city. It would go on to kill 12 more people before an antivenom finally existed in 1981. In July of 1950, a 20-year-old amateur snake collector named Kevin Budden travelled from Sydney to Cairns with one dangerous goal: capturing a live coastal taipan for medical research. On the 27th, he found one at a rubbish tip on the edge of town and caught it with his bare hands. Bitten on the thumb in the struggle, Budden still refused to let the animal go, hitchhiking to safety with it clenched in his grip and insisting doctors treat the snake as a priority alongside himself. Paralysis set in within hours. He died the next day. But the venom milked from that same snake became the foundation of the world's first taipan antivenom, released in 1955 and within a year. It saved the life of a 10-year-old boy in far north Queensland. Decades later, and well over 1,000 kilometres south, Tasmania quietly recorded a different kind of anomaly: a cluster of fatal allergic reactions to the sting of the jackjumper ant, an insect found nowhere else in the country at anything like this severity. Otherwise healthy adults were going into anaphylactic shock within minutes of a sting that most Australians would barely register. It was strange and serious enough that Tasmania became home to the world's first dedicated ant venom desensitisation program, treating hundreds of residents against a creature most Australians dismiss as a garden nuisance. Then, in 2002, 2 tourists, months apart, died on the Great Barrier Reef after swimming through water that looked, by every visible measure, completely empty. Both collapsed with soaring blood pressure and unbearable pain hours after the initial sting had already faded from memory. Their deaths were eventually traced to Irukandji syndrome, the work of a jellyfish, roughly the size of a fingernail, functionally invisible and capable of triggering a fatal spike in blood pressure from a sting most victims barely notice at the time. Before 2002, most divers on that reef had never even heard its name. Naturally, stories like these rarely stay contained to medical journals. Rumours spread of curses on the land, of impossible mutations, of a continent seemingly built to kill. If you're waiting for the supernatural explanation, keep watching, because what researchers actually found is even stranger than folklore. Subscribe now and let's separate the myth from the biology. Inevitably, the internet did what the internet does. Search long enough and you'll find claims that Australia's wildlife was somehow designed to kill people specifically, that its animals are uniquely, almost supernaturally aggressive, an entire genre of jokes and memes built around the idea that the continent itself is actively hostile to human life, down to the plants and the water. You'll also find the old joke about the drop bear, a mythical carnivorous cousin of the koala, said to fall from trees onto unsuspecting hikers. It's worth being clear about this one. The drop bear has no basis in ancient tradition whatsoever. It's a distinctly modern invention, first appearing in the later 20th century as a prank locals play on tourists, proof that not every Australian legend carries centuries of hard-won knowledge behind it. Some are simply jokes. The real investigation, carried out by toxinologists and evolutionary biologists rather than folklorists, tells a very different story than either the curse or the joke. These venoms were never built with humans in mind. Long before people arrived on this continent, they were fine-tuned for one purpose: killing small, fast-moving prey rodents, birds, invertebrates as quickly as possible, in an environment without the competition found on other continents. Humans are, biologically speaking, an accident of overlap. Our nervous and circulatory systems happen to share enough in common with the intended targets that chemistry built to drop a rat in seconds can prove catastrophic in us too. And here is the detail the mythology conveniently leaves out, by world standards. Actually dying from any of it is remarkably rare. Australia now averages only 1 to 2 snakebite deaths a year nationwide, down from more than a dozen a year a century ago, despite housing the most toxic snake venoms on the planet. The inland taipan, the single most lethal of them all, has no confirmed human fatality attached to its name at all. It is simply too shy and too remote to bother with us. The snake that kills the most Australians isn't the most venomous one, it's the eastern brown, precisely because it tolerates farmland, gardens and roadsides, placing it in regular contact with people. The danger was never really about how deadly a creature could theoretically be. It was always about proximity. So if it isn't a curse, and it isn't some conspiracy of aggressive design, what is actually happening here? The grounded answer may be more unsettling than either. What tens of millions of years of isolation produced is a set of biochemical weapons refined to an almost absurd degree venoms shaped by a landscape so vast and competition so sparse. That evolution had the luxury of perfecting rather than merely adequating its killing tools. The inland taipan's venom doesn't need to work on humans to be terrifying. It only needs to be the most efficient possible way to stop a rat's heart in under a minute. And it happens to be devastating on us as collateral. That is arguably more disturbing than any curse. A killer this refined was never even trying to be one, and even now, the platypus's venom, older than most dinosaurs, appears to exist not for hunting at all, but for combat between rival males. A detail that still leaves evolutionary biologists without a fully settled answer. Then there is the setting itself. Layer that biochemistry onto the geography, described earlier, a continent of punishing heat, cracked clay flats, and genuine bone-deep remoteness, and the real danger comes into focus. It was never really about which animal carries the scariest venom. It's about what happens when a bite occurs 3, 4, 5 hours from the nearest hospital, in country too vast and too harsh for help to arrive quickly. Venom is only half the equation. Distance is the other half, and it is often the more decisive one. This is precisely the danger Aboriginal communities encoded into lore and story for tens of thousands of years, long before toxinology existed as a discipline, not fear for its own sake, but a tested, accurate understanding of which country demanded caution, That knowledge hasn't vanished. Indigenous ranger programs across the country increasingly work alongside scientists today, pairing traditional land knowledge with modern venom research. The old warnings and the modern data were never really in conflict. They were describing the same threat in two different languages. 12 species, one continent, tens of millions of years of isolation, refining creatures this precise, this ancient, this efficient. Not cursed, not supernatural, simply the patient, honest math of evolution, running undisturbed longer than almost anywhere else on Earth, arriving at something that looks, from the outside, almost impossible. Science and ancient knowledge rarely turn out to be enemies. More often, they're two different paths to the same hard-won truth, reached centuries or millennia apart. Which of these 12 unsettled you the most? Tell us in the comments, and if you want more of the planet's oldest, strangest mysteries, subscribe and we'll see you in the next one.